Hey, groovy people, I'm John. I'm a retired math teacher. I taught math for 36 years. I also taught SAT prep for over 15 years with a really cool dude. He did the English, I did the math, and the SAT are addicted to the Pythagorean triples, you guys. It comes from the Pythagorean theorem. So let me show you some Pythagorean triples. So there's infinitely many, but the most common ones we'll cover in here, you guys. So the Pythagorean theorem is this, you guys. So it has to be a right triangle, and C has to be the hypotenuse, which is opposite the right angle right there. And it goes like this: A squared plus B squared equals C squared. Everybody's heard of that before. Just make sure C is the right angle right there. And this, or the hypotenuse. I'm thinking ahead. Um, and this is what the Scarecrow said when he got his brain in The Wizard of Oz, was the Pythagorean theorem. And he says it so fast, and I wasn't aware of that until I started studying math, and so back in the 80s. So that was a cool journey. All right, so is this a right triangle? Are the following right triangles? So if it is, then that would mean 2 squared plus 3 squared equals 4 squared. So that's what we're going to check. We're going to see, is 2 squared plus 3 squared equal to 4 squared? Well, 2 squared is 4, 3 squared is 9, and 4 plus 9 equals 13. 4 squared is 16, and 13 doesn't equal 16, so it's not a right triangle. It's a triangle, it's just not a right triangle. So how about this one? 3, 4, 5. And this is going to be the most common Pythagorean triple here, because 3 squared plus 4 squared, 3 squared is 9, 4 squared is 16, and 5 squared is 25, and 9 plus 16 equals 25. So yes, it is a right triangle, and this is called a Pythagorean triple, you guys. 3, 4, 5, because it satisfies the Pythagorean theorem, and so it's called a Pythagorean triple. And so I'm going to call them P triples, you guys, just so I don't have to write that big long word all the time. So P triples, if I took 3, 4, 5 and multiplied everything times 2, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. It turns out that's another P triple. 6 squared plus 8 squared does equal 10 squared. 6 squared is 36, 8 squared is 64, 10 squared is 100, and 36 plus 64 equals 100. Okay, if I did 3 times 3, that equals 9, okay? And then 4 times 3. So if I multiply all these numbers by the same number, it gives me more P triples. 4 times 3 is 12, 5 times 3 is 15, and it turns out 9 squared plus 12 squared, 9 squared is 81, 12 squared is 144, and 15 squared is 225, and 81 plus 144 equals 225. So I can multiply 3, 4, 5 P triples by any number, any constant number, as long as I multiply all of them, and it gets us more P triples. And so here's 3, 4, 5 times 2, 6, 8, 10, P triple. Here's 3, 4, 5 times 3, 9, 12, 15, another P triple. Here's 3 times 4, 4 times 4, 5 times 4, it's another P triple. 3 times 5, 4 times 5, 5 times 5. In fact, 3n, 4n, 5n are all P triples. They're all multiples of a 3, 4, 5 P triple. Now, there's other P triples that are not multiples of 3, 4, 5. Here's one right here. 5, 12, 13. 5 squared is 25, 12 squared is 144, 13 squared is 169, and 25 plus 144 is 169. So this is another P triple. It's a 5, 12, 13 P triple. So if I multiplied 5 times 2, 12 times 2, 13 times 2, that's another P triple. 5 times 3, 12 times 3, 13 times 3, another P triple. 5 times 4, 13 or 12 times 4, 13 times 4 is another P triple. So all of these are P triples right here. I could have done 5n, 12n, 13n. I don't know why I chose 20n, 48n, 52n, but whatever. They're all 5, 12, 13 multiples of 5, 12, 13 P triples. So it just saves yourself time if you know some P triples. Here's another P triple, 8, 15, 17. 8 squared is 64. 15 squared is 225, 17 squared is 289, and 64 plus 225 equals 289. So it's another p-triple, 8, 15, 17. So times 2, here it is times 3, here's 8, 15, 17 times any number, and it'll get me more p-triples. These are 8, 15, 17 p-triples. Okay, there's all kinds of p-triples. I'm just showing you the most ones that you will see, that you will likely see on the SAT. So 3, 4, 5, 6, 8, 10. So here's 3 times 2, 4 times 2, 5 times 2, 3 times 3, 4 times 3, 5 times 3. I could keep going all the way off this paper. I could do it with the 5, 12, 13 also. I could do it with the 8, 15, 17 also. This is another one. 7 squared plus 24 squared equals 25 squared. So if I see a right triangle and I see these lengths on a right triangle and I see 2 of them, then the third one's going to be one of these right here. Just make sure that the hypotenuse is always the biggest number. So the hypotenuse has to be opposite the right angle. Okay, so let's try some of these here, you guys. So real common SAT questions, you guys. Find or solve for x here. Now, if you don't know the p-triple, I'm going to show you the Pythagorean theorem. 7 squared plus x squared equals 25 squared. Okay, we just showed that right there. Do you remember what the number was that's missing with it? We'll come back to it. Okay, so if I go ahead and do x squared, I did x squared first, plus 7 squared equals 25 squared. 7 squared is 49, 25 squared is 625, and so we subtract 49 on both sides and get 576, and that's what 24 squared is, so x equals 24. Okay, you can do the Pythagorean theorem when you see these on the test, and you're kind of wasting some time because if you know, because you're given only time to test, you have to do it in a certain amount of time. Look, I knew it was going to be 24 because it's the numbers that matches with this p-triple right here. We had 25, we had 7. Remember, this was the hypotenuse on that, guys. So I knew that third side was going to be 24 right there, okay? So how about this one right here? Okay, so there it is right there. I knew that was 24. How about this one right here? Okay, 8, 15. Do you remember the number that goes with that? 8, 15. It's good if you do. And if you don't, you can use the Pythagorean theorem, but there it is right there. 8, 15, 17. So I knew it was going to be 17. So if you wanted to, I would focus on these p-triples right here for you guys taking the SATs, you guys, and that you'll see one of those at least once, you guys. I knew x was going to be 17. I could have done the Pythagorean theorem. 8 squared is 64, 15 squared is 225, and 64 plus 225 is 289, and when I square root 289, I'll get 17. But I knew it was going to be 17 because it was 8, 15, 17 p-triple right there. All right, here's one that has a bunch of stuff right here. It says, in the figure, they want us to find the length of AT. So here's AT over here. Okay, let's look at this. If this is a right angle right here, then this has to be a right angle right here. So I have 2 right triangles right here. Here's 2 sides of the right triangle on this side right here. Do you remember the missing piece? 5 blank 13. Okay. If you don't, here it is right here. So, and then I'm going to use that piece for the other right triangle. So it was 12, 5, 12, 13. It was a 5, 12, 13 p-triple right there. So I know that that piece is 12. Okay, and then remember, we want to find this length right here, the length of AT. Here's another p-triple, 9, 12, blank. Do you remember that one? 9, and if you don't, you can use the Pythagorean theorem, but you're limited time, so you're just going to kind of be wasting time. So 9, 12, 15. So that's our answer right there. This has to be, sorry, these papers get a little overwhelming after a bit. So it has to be 15 out there. So anyways, that's a good p-triple lesson that'll get you successful when you take the SAT. All right, you guys, I'll see you later. Peace out.